Just when experts thought they had seen it all, along comes the James Webb Telescope to show them that bizarre cotton candy planets are out there too. But what may sound like an amusing cosmic fair suite, at first glance, actually embodies a real mystery. After all, the fluffy exoplanets appear much too light for their size, and they push our current models to their limits simply by existing. On paper, everything seems so clear. According to our established theories, gas giants the size of Jupiter form when they have formed a solid core of at least 10 Earth masses in the early days of their home systems. From then on, the planetary core's gravity ensures that it can hold on to a thick gas envelope, even in the face of strong stellar winds. Well, at least that's the theory. But if we take a look at the real discovery in space, we see that there are also some exoplanets out there that pose serious problems for our current models of planet development. The first of these outliers was added to the star charts back in 2017. Located around 212 light-years away from us and christened with the scientific name WASP 107b, this alien world orbits its host star in less than 6 days. The first observational data already suggested that we are dealing with a gas planet about the size of Jupiter. But the follow-up studies over the next few years were to finally bring a rather confusing circumstance to light. In detail, the experts focused on the so-called radial velocity. They analyzed the tiny wobbles of the parent star caused by the gravitational influence of its planetary companion. This method makes it possible to determine the mass of the exoplanet, and the bottom line was the surprising finding that WASP 107b weighs in at just 30 Earth masses. In other words, although the celestial body is as large as the mighty Jupiter, it only has 10% of its mass. Against this background, the experts' model calculations showed that the solid core can have a maximum of 4 Earth masses and that the planet is extremely fluffy. To be more precise, the extrasolar gas giant has an unusually low density, reminiscent of candy floss. But how could a planet with such a low density even come into being? And above all, how did it prevent its mighty gas envelope from escaping into space? The latter seems all the more puzzling given that, as already mentioned, WASP 107b orbits its host star at a very close distance. And even if these profound questions could not be answered with absolute certainty, at least one thing seems certain to astronomers. The mysterious candy floss planet embodies a, quote, absolute outsider, a unique cosmic eccentric that turns the known mass-radius relationship of planets on its head. And that's absolutely right. But if the scientists at the time had already had the companions of Kepler 51 on their radar, they would have known that such absolute outsiders are ultimately much more common in the vastness of the universe than previously thought. The surprising discovery of the James Webb Telescope. In terms of mass, the Sun and Kepler 51 can confidently be described as similar. But the differences in terms of planetary companions are all the greater. Located in the constellation Cygnus, around 2,600 light-years from us, this young star is the central star not only for 1 or even 2, but for 3 candy floss planets, if you like. The mystery surrounding the formation and maintenance of the gas envelope is therefore threefold here. And to finally shed some more light on the cosmic darkness, a research team led by Jessica Libby Roberts of Pennsylvania State University took a closer look at the planets of Kepler 51 for the first time using the James Webb Telescope. But when the experts pointed the Webb telescope at the star shortly before the predicted transit, they were in for a big surprise. The shadow cast by the planet began much too early. The researchers had demonstrated extremely poor timing, and so it happened that they saw not the beginning, but only the end of the planet parade. Expressed in numbers, this means nothing more than that the exoplanet Kepler 51d passed in front of its star a full 2 hours too early. The fact that the experts even noticed it at all was thanks to the fact that they had started their observations a few hours earlier to record the normal planetary starlight as a reference. Now, a transit deviation of a few minutes can be explained, but the situation is quite different in the case of the discrepancy of 2 hours. But what was responsible for the planet's jump start? Well, that was the question. and co-first author Kento Masuda of the University of Osaka frankly admitted that the early emergence of Kepler 51d really baffled him and his colleagues. No matter how the experts turned and twisted their three-planet models, there was simply no scenario that could explain such a large deviation in the expected transit times. However, it could also be ruled out that the James Webb Telescope had made a mistake. After all, the early transit was also confirmed by the Hubble Space Telescope and several Earth-based telescopes. Ultimately, the solution to the mystery lay in a model that was expanded to include a fourth additional planet. The corresponding celestial body apparently orbits Kepler 51 further out and on a more inclined orbit. As a result, from our earthly point of view, it does not pass directly in front of its host star, but it has a significant influence on the movement of the other planets through its gravity. Furthermore, the researchers found that this can be best explained by the existence of a gas planet with a mass similar to that of its three counterparts. So, the planetary system around Kepler 51 is now not only one member richer, which probably orbits its star on a wide circular orbit with an orbital period of 264 days, but also one more enigmatic lightweight, christened Kepler 51e. Its presence does slightly increase the previous mass estimates, but the celestial bodies still remain too light to be reconciled with our established models of planet formation. This is compounded by the fact that we're dealing here with a cotton candy quartet, although most of these fluffy planets only occur singly in their home systems. As things stand, however, we cannot rule out the possibility that even more exoplanets are hiding beyond the orbit of Kepler 51e. And researchers are now hoping to use the high-resolution spectra of the James Webb Telescope to further unravel the secrets of the puffed-up worlds. This unique planetary family amazes researchers. Aside from the cotton candy-like examples, the field of exoplanet research has also produced some other surprising results in the recent past. While the planetary similarity around Kepler 51 only deepens the existing mystery, astronomers have detected a system elsewhere that is making headlines with its surprising diversity. More specifically, it's a system around the star WASP 132, about 400 light-years away, which is home to a super-Earth, then a hot Jupiter, and further out, a large ice giant. And while the term super-Earth merely refers to the mass of a large rocky planet without making any statements about its composition or even habitability, hot Jupiter refers to exoplanets with a mass similar to that of Jupiter, but which, at the same time, have a significantly higher surface temperature than the king of our planetary system. And if your gentle journey to the subscribe button has not yet been started, you're welcome to change that now. Press the thumbs up and click subscribe to never miss a new video from our channel, Digital Discoveries. We'll see you soon.